Hi, good morning to everyone. In this session, we have to discuss about the definition and the theories of corrosion. First one is the definition. Gradual distillation of metals into their metal oxide is called as a corrosion. This corrosion takes place when metal is exposed to the atmosphere. So, corrosive agents from the atmosphere attacks the metals and converts that metal into metal oxides. We know that metals are not existing in its pure form, metals are existing in combined form, that means ore form. We are extracting that metals from their ores by different chemical treatment and we are converting that into zero oxidation state. So that metal with zero oxidation state is highly unstable and it is having more energy and it tries themselves to convert into their thermodynamically more stable state, that means their ore form. So this is just like a reverse to extraction of the metals. So there is first one is the dry corrosion or a chemical corrosion. This type of corrosion takes place in the absence of atmospheric moisture. So here that atmospheric gases like oxygen, carbon dioxide, hydrogen can directly attack the surface of the metal and converts that metal into metal oxides. These gases follows that absorption mechanism and the product which is existed between in this corrosion reaction starts to deposit at the spot of corrosion. That means this deposition of oxide layer takes place where that corrosion occurs. So action of dry steel on iron surface is the example. Next one is oxidation corrosion. This type of corrosion takes place if that atmosphere contains more oxygen. So that oxygen attacks the surface of the metal, converts that metal into the metal oxides. Alkali metals and alkali earth metals are more sensitive towards this oxidation corrosion. So rate of this oxidation corrosion is depends upon the nature of the oxide layer that is formed between the atmosphere and the metal. So mechanism is given here. First, metals are converted into metal ion by releasing electron, that is called as oxidation. This oxidation takes place at the anode and electrons which are existing in the anode has been consumed by the atmospheric oxygen and atmospheric oxygen is converted into oxides. Now these oxides combined with this metal ion and it has been converted into metal oxides. So that rate of the corrosion mostly depends upon the nature of oxide layer. If oxide layer is more stable, then that will act as a barrier between the atmosphere and the metal and does not allow the corrosive agents to diffuse inside that metal. That means if corrosion proceeds for more long duration, then thickness of oxide layer becomes more and it becomes more stable on the surface of the metal and it does not allow the oxygen or some other corrosive agents to enter inside the metal. Next, unstable. If the oxide layer is unstable, then metal oxides are converted into the pure metal and oxygen. So metals like silver and gold, platinum are more inert towards the atmospheric oxygen. Even if it is forms metal oxide also, immediately that has been converted into metal and oxygen, etc. Next, volatile. If metal oxides are more volatile, then they leave the metal surface as soon as they are formed. Now that fresh metal is exposed to the atmosphere and it starts to corrode. So examples are molybdate is given here. So next, porous. If oxide layers are having more pores, then atmospheric oxygen can enter into that pores and it may corrode that metal surface. Other gases like SO2, CO2, H2S are also more corrosive in nature. Next, liquid metal corrosion. This type of corrosion takes place when liquid flows on the surface of the metal. So this liquid may dissolve that metal or this liquid may diffuse inside the metal. Because of this, metal can be corroded easily. So examples given here: when sodium metal flows through the nuclear reactor, then it may corrode the cadmium layers present inside that nuclear reactors. Another one is wet electrochemical corrosion. This type of corrosion takes place in the presence of moisture. This corrosion can take place when metal is kept into electrolyte or two dissimilar metals are placed in the electrolyte. Anode and cathode has been fixed and electron flow can be from anode to cathode and this follows electrochemical reaction methods. So next, mechanism is given here. Initially metal can be converted into metal ion by releasing electrons. These electrons can be either consumed by H plus ions or atmospheric oxygen depending upon the electrolyte. If electrolyte is acid, then H plus ions are supplied by the electrolyte and these H plus ions consume these electrons and converts into hydrogen gas. If electrolyte is neutral, then atmospheric oxygen can be converted into hydroxyl ion by abstraction of two electrons from the anode. So these can be explained further. So first one is the evaluation of hydrogen type corrosion. Here iron is there, iron is converted into ferrous by releasing 2 electrons. This is called as the anode. After that, these 2 electrons are consumed with H plus ions from the electrolyte, and hydrogen gas is evolved. This is called as the cathode. So the electrons are continuously flowing from this anode to cathode, and all the iron is converted into iron oxides. Next, oxygen type corrosion, absorption of oxygen type corrosion. This type of corrosion takes place in neutral medium. So in this neutral medium, initially that iron starts to oxidation, iron starts to corrode. That means all the iron is converted into ferrous ion by releasing 2 electrons. These 2 electrons are consumed by atmospheric oxygen and H2O from the electrolyte, and it has been converted into OH minus ions. So these OH minus ions now combines with ferrous, and ferrous hydroxide will be formed. This ferrous hydroxide is unstable. Further, it has been corroded. That means it undergoes further oxidation, and it has been converted into ferric hydroxide, where iron is in +3 oxidation state. Next one is the difference between chemical or dry corrosion and electrochemical wet corrosion. So dry corrosion occurs in the absence of atmospheric moisture, and electrochemical or wet corrosion takes place in the presence of moisture or electrolyte. So this dry corrosion involves direct chemical attack by the gases. This involves the setting up of a large number of electrolytic cells. So that corrosion products can be deposited at the spot of corrosion. Here products, that means corrosion products, can be deposited at the cathode. So here cathode is uniform throughout the surface. Here cathode is not uniform. It depends upon the nature of the anode and cathodic metals. So it follows absorption mechanism, but it follows electrochemical reactions.